I'm Hi, I'm Devna AV, BS Electronics ES student. Today we are doing week 4 lab experiment where we have to plot the VI graph for a forward biased and reverse biased diode. And we will be making the circuit which looks exactly like this. And I have already done the circuit over here. And we have done this all set up, so now we can proceed to checking whether it works. So we use pixel pulse and the multimeter for it. And now we change this to constant. And let's just say this is a 5, so let's make it 0. Enter. And at 0, the value of the multimeter is also 0. Then we change it to 0.5. Then also it turns out to be 0.005. And then we change it to 5. As you can see, it increases. And yes, we get the value of 3.960 and all that. So, which means that we have gotten it correct. And we can also check for 0.9. We get 0.52 and all. So we can get these values and plot the graph which we need. And this is the graph that we get, which at the critical point of 0.5 changes the direction and tends to become constant. And next we move on with making this forward biased, a reverse biased setup by reversing the direction of the diode. And then we proceed to check how the pixel pulse works for this. And here, when we change, when it's 0, it is 0. And when we change this to 5, it is still gonna be 0.00. And now we can move on with the next part of the experiment, where we have a circuit as shown over here. And we're going to construct the exact same circuit. And we're going to give a 2.5 DC voltage to the setup. And then we're going to connect the channel B over here and channel A over here. And then let's see the pixel pulse. This is basically a half-wave rectifier setup we're having, and I'll give a sine wave input. And this is how it looks like. But let's change the frequency to 50 Hertz. So yes, you can see a half-wave setup. The graph goes like that, right? That's a half-wave setup. And so we have done this part of the experiment. Now we can move on with introducing a capacitor to see how the half-wave, like how much of it has been rectified using a capacitor. Okay, now we move on with a LED, which also sometimes behaves like a rectifier because it's also light emitting diode. And this blinking happens because we have a 5-volt input source. And if we decrease it, the blinking goes down. And also we can use a multimeter. Yes, one sec. We have to do one more connection. we connect this over here. It was in here. Connection issues. And then we press enter. Make it a 5. This is because we have changed the polarity. Anyhow, we got the readings already over there. Now we can move on with the forward biased PN junction diode, and we can make the VI characteristic of it too. So this is the graph we are getting. So we make it as 0. It remains the same. And we will also use this multimeter to check the current readings, which is crucial. So at 0, it is 0. Then we move on with 5. There happens to be an issue over here because the connection is not together. Yes. And now we connect this over here. This over here. And then we use this to read the voltage readings. Oops, I think I missed this part. There we go. This goes over here. Yes, as you can see, since it is a forward bias, we get the value of 15 point and 17 point, 18 point something when we have a voltage, input voltage of 5, and when we decrease it, let's say 3, these readings also gets down. It becomes 4.27, etc. And we plot the graph as such for this setup, and we get a graph like this for the forward bias part. And then we move on with the reverse biasing, where we simply change the direction of the diode. And we see the pixel pulse reading. Let's just this is a 50 hertz. This also behaves like a rectifier, as you can see in the graph. And now we take the different readings. Say it is for 0, 0. Point. Okay. And we get 0.13 for that reading. And now we move on with a higher value, let's say 1.2. We get it to be 14 minus 0.30, and so on. And then we move on with plotting the graph for the reverse bias part. Where is it? And we get a graph like this because they're negative values for the reverse bias. And when we integrate both of it, we get a graph similar to this, which is perfect. We have verified the forward and reverse bias part of this question, and we have done all parts of this question successfully, so thank you.